let's get this event started with a product update on Mari. To begin with, I'd like to touch on what the Mari team has accomplished over the last year. Mari 4.6 was a landmark release for us. Many of you had told us that it had been our best release in years. Following from our material system introduction in Mari 4.5, 4.6 brought geochannels to Mari. Geochannels allowed artists to integrate baked mesh maps into their material presets, ready to be applied across the team's projects to get material looks more grounded into the shape and form of the object they were applied to. With the material system, we've been encouraging artists to take advantage of Mari's incredibly powerful node graph for material designing. So we took steps to improve the user experience by making nodes collapsible, making parallel material streams display as a single connection, and improving our auto layout algorithm for easier to read left-to-right look development workflows. We also included a wide array of new filters and patterns for increased proceduralism in your Mari workflows. These include a live curvature, scratches pattern, as well as all new position and camera projection procedurals to enable decal placement workflows. Then rounding off 4.6 v1, we got new vendor shaders from Chaos Group and the 3D Light team, helping streamline look development between Mari and Katana. For the Mari team, we recognize that day-to-day usability is just as important as fundamental workflow features. With each maintenance release, we strive to address even the smallest niggle or annoyance reported to us by you to make sure they become a thing of the past. Our latest maintenance release is Mari 4.6 v4, and we're super excited about the benefits it brings to look development artists. For a start, we've introduced a limited patch range for bake points. Where before a bake point would flatten and force bake all patches of your model, a new option on the bake point node allows you to limit the patch range that is processed on each bake. Gone are the days of baking 20 or 100 patches of your model when all you wanted were 2. Now you can have more fine-tuned control when reducing project complexity with bake points, saving you tons of time so you can spend it creating something incredible. The Breakpoint node also enjoys a newly introduced export on bake option, perfect for look development artists working across Mari and Katana. This automatically exports the latest flattened texture maps to a predetermined file sequence on disk on each Breakpoint update, ready to be picked up by your preferred renderer, accelerating the workflow between Mari and programs like Katana. We've introduced a local space transform mode. Transform handles are now orientated with the object or locator's rotation, so that transformation along the rotated axis is now possible. Artists can switch between transform handles more effectively without having to slow their pace thanks to an increased handle hit area. We've updated the visual appearance of edge connections in Mari's node graph, finding a compromise between straight and curvy depending on the position of the two nodes being connected together. There are a lot more small tweaks and enhancements for both artists and developers in Mari 4.6 v4, so I do encourage you to read the release notes on learn.foundry.com to gauge the full picture of this quality of life release that we're incredibly happy with. Moving on, I'd like to show you some of the features we're currently working on for our next major release. Mari continues to build on the material system with the introduction of custom procedurals and a brand new shelf. We've refreshed the shelf UI to be sleeker and more user-friendly, while all the Mari system shelves and content are still at your fingertips. The shelf is divided into two main sections. The shelf panel on the left, which can be used to navigate between your shelves, and the shelf items panel on the right. The shelf panel dictates which items appear on the adjacent panel depending on your current selection. Shelf item thumbnails can now be scaled using the Resize Thumbnail button at the top of the right-hand panel. Shelves can now be grouped for better organization, and selecting the group name on the left will show all items nested within its contained shelves. Our new shelf brings artists the ability to search and filter shelf content across both single and multiple shelves. Search results can be restricted by shelf item type by using the filter drop-down menu. You can search for shelf items by name or by tag. Tags give you more power to decide how you want to organize your content. A material's tags, shader model, name, and list of geochannels used is now displayed in a rich tooltip. You can also edit shelf item tags in place using the Edit Tags tool in the right-click menu. Any existing tags are displayed in the drop-down menu to make conforming to existing tag names easier. We are really looking forward to seeing how the new shelf transforms how teams can manage and share their libraries of materials, brushes, and textures. Also coming to Mari are custom procedurals. These are a mix between our Gizmo and material systems, in the manner that you can author your own procedurals, like you would a Gizmo, except when you export them, all reference texture maps will be bundled into a single package file, with an automatic thumbnail being generated for display in the shelf, like materials do. While authoring your procedural, you can designate the intended use for it in the Export tab. Color procedurals will utilize color management. Scalar procedurals can be used for non-color patterns like roughness or normal textures. And procedural mask. These allow you to add your published procedural directly to a layer as its mask. And like materials, all promoted controls will appear in the Layer Properties panel. Procedural masks really open the creative possibilities for generating smarter masking when utilizing geochannels. For all our no-graph artists out there using the material system, we will also be bringing your most requested feature in our next major release, the multi-channel Breakpoint. You'll be able to choose which streams to batch bake, as well as use our new limited patch range feature across all material streams. The multi-channel Breakpoint will give artists fine-tuned control to increase project performance when using complex procedural materials in large multi-UDIM projects. We can't wait to get these features in your hands, so keep an eye out on our community forums for updates and beta releases. Looking forward, Mari has always positioned itself in the heart of a studio's look development pipeline, and we see the future of studio pipelines being built around the Universal Scene Description Format, or USD. The launch of Mari 4.64 also saw our first step into the world of USD. Originally developed at Pixar, Foundry has open-sourced a plugin to import USD meshes and Xforms into your Mari project. Due to the limitations of Mari's C API, the mesh importer has a simple interface for now, compared to other core importers like Alembic, but it features all the options you need to get your asset into Mari. You can import the entire stage or specify which meshes to import by its prim name. You can choose which UV set to use as well. The plugin also allows you to flatten stage animation into your project. The USD Mesh Importer also has native support for open subdiv tokens. So in the Mari subdivision UI, you can pick the Use Source option to allow the USD file to drive all the schemas and interpolation methods for your subdivision. Once you have your USD models in Mari, you can texture them as you would normally with Mari's high-quality painting tools. So this is what USD in Mari looks like now. However, we are planning far more interesting developments for the next year. Our first challenge will be to make Mari the look development tool you use to author your preview looks and allow you to publish these into your pipeline as a USD shade layer. We want to bring the USD preview surface into Mari as a shader, from where you can plug your channels into it and export a preview quality USD shade document, referencing the original USD document you used to start the project. With preview looks published from Mari back to USD, we see studios gaining the ability to streamline preview looks into viewers via Hydra's HD Storm Render Delegate, achieving a much richer visual experience in shot production applications. And beyond previewing, we also want to extend this workflow to author renderer native looks with USD Shade, and further streamline look development from Mari to Katana. We see Mari having an incredible future in your look development pipeline. Thank you for watching. Alright, I hope you guys enjoyed that little look at what we're working on and what's coming. Now I shall hand over to Jens, who's going to talk about Mari as a platform.
First of all, thank you to the Foundry for having me on this webinar. So in this talk, I want to take a look at Mari more from a pipeline point of view. Usually we talk about it from an artist's perspective, for example, how to author materials and textures or use the node graph, layer stack, etc. But one of the big reasons Mari still is the central element of many texturing pipelines, especially in the VFX and feature animation industry, is its extendability and the fact that you can really tightly integrate it into your pipeline. In many VFX and animation studios, you will find Mari to sit in the center of texturing, where all elements end up being fed into. So this can be texture data from other applications or texture data created in Mari itself or data from libraries. It doesn't really matter. It all ends up in Mari oftentimes and is then distributed from there to the next step, which is usually look dev. Let's take a quick look at the different elements of the Mari API that allow some of this integration and extendability, and some of its more high-level concepts before we take a look at some practical examples where I apply them. So the Mari API can be split into several elements. The OpenGL API, which you can use to create your own custom shaders and nodes, the Python API to automate and script tools, And then sort of as a subset of some of these, there's the ability to write your own filters and blend modes, which use a combination of OpenGL and Python. Finally, there's the C API, which to my knowledge at least is mostly used by studios to write their own geoloaders, integrate their own formats, etc. But it obviously offers a lot more than that. In terms of practical applications of all these API elements, it really comes down to two fields. The first one is having Mari talk to different parts of your pipeline because it obviously does not exist in a vacuum. And the second part is making artists' life easier and give them more tools to produce the actual work inside of Mari. The pipeline part is oftentimes quite studio specific, but the general themes are usually that you want to automate your project setup. So for example, sending data from Maya into Mari and having the artist's project set up for them with correct templates, etc. You also want to manage the export location or for example, launch a post process after exporting for texture map mapping or something like that, but also publishing. And for example, Shotgun natively comes with a Mari integration, so you can directly publish from Mari into Shotgun or use the existing framework to write your own publisher, which you can do with or without Shotgun really. Talking about publishing, especially on the bigger VFX projects where assets can sometimes have thousands of textures associated with them, exporting can be a real time factor. So oftentimes studios will go ahead and integrate Mari onto their render farm. Mari can be run like in a terminal mode, so without the UI, just via a shell. And you can also export data chunks from Mari as a separate format or as a data format, and then use another machine to handle all your exporting and baking and flattening, so the artists can keep on working on their own machine without being locked out. Now the making artists' life easier part is where I do a lot of work with Extension Pack, because obviously I use Mari to create textures myself in my day job. So a lot of the time I'm just quite lazy and I want to make my own life easier, and sort of as a knock-on effect, others benefit from it because I embed that stuff into Extension Pack eventually. One of the examples of this is probably the most used feature of Mari Extension Pack, and it's called the radio node system. So radio nodes are basically a combination of Python tools and OpenGL nodes, and they allow the artist to send data from one point in their node graph to another without having like an annoying connection line cross all the way through their graph. The way it works is by creating a so-called radio transmitter node. The transmitter basically passes data through without any processing, just serves as a lookup point in a node graph that has a unique ID. So if we look at the code of this transmitter node, you will see there's absolutely nothing happening inside there. Input is literally output, and all I really care about is this ID field at the top, which identifies the node type. The radio node itself also does very little, but it has two input ports, of which only one is visible and the other one is a hidden input. On top of that whole system just sits a Python script that parses your node graph for any radio transmitter, so nodes that match that particular ID we saw earlier. And when the user chooses to connect a radio node to a selected transmitter, the Python script just creates a hidden connection between the radio transmitter and the hidden input of the radio node. Here I'm toggling the visibility of the connection line, which switches the connection from the hidden input port to the visible port and back. Building the connection between the radio transmitter and the radio node itself is fairly trivial from a code point of view. So here I'm just building a list of all node IDs in your current node graph, and then setting the selected radio node's input to a node, which happens here. Another more complex example of interaction between OpenGL nodes and Python scripts is the extension pack mask shelf and the content it ships with. The mask shelf allows the user to save entire graph snippets as a preset, including any image data it uses. By default, extension pack ships with around 500 presets, which include procedurals and so-called smart masks that allow you to procedurally generate wear and tear on your model. The presets introduce a high level of proceduralism into Mari, allowing you to create complex effects that otherwise would be a lot harder to achieve. If we look at this preset, for example, you can see it is built using a subgraph of custom nodes, and then parameters are exposed to the node, so the user has easily accessible controls. These more geometric presets are made up from a series of nodes that are part of what I call the pattern engine. These custom nodes allow you a lot of freedom, and as you can see here, I can change the pattern completely very easily. You can then save this new preset to the mask shelf, and since the shelf uses a shared location on disk, other artists in the team will be able to see the new presets, making collaboration quite easily possible. Apart from adding completely new features, Mari's API also allows amending of functionalities to existing standard Mari tools. Here I'm adding presets to the template field dropdown of the material ingester tool, which is a standard Mari dialog. Mari's UI is based around the concept of actions. Each item in the UI is an action that can be searched, removed, and replaced via scripts. By replacing these standard Mari material ingester actions in the menu with my own created action, I can edit settings each time it is launched and then call the original ingester action in the end. This is a great way to make subtle enhancements to Mari without the user having to use different tools than they're used to. To wrap this up, let me show you a time-lapse video of some actual texture work, where we can see a variety of enhancements made using the API elements we discussed. I'm using here a series of material templates that have been added to the Mari shelf on startup using the Shelf Python API. By launching scripts whenever the user is in transfer mode, I'm able to dynamically add standard Mari locators to the material, making it possible to directly modify their projections in the viewport without having to manually create these locators first. Using the standard Mari texture set palette, I'm loading Megascans materials here into the image manager. From there, I'm ingesting them into my materials using a custom tool and user customizable naming conventions, which quite greatly reduces the time to apply such library data. Since all attributes of a layer or node are scriptable, you always have full control over all elements of a node via the API, which is how I'm achieving this. So if you haven't looked at the API, I would definitely recommend you do so. Even if you're an artist with basic Python skills, it'll help you a lot to automate certain tasks. And I'm not a coder either, so if I can do it, you can do it. So yeah, that wraps it for me, and thank you for listening.
Thanks very much, Jens. Now we want to Christian from Mr. X talk about scary stories to tell in the dark.
Hi everyone, my name is Christian Camarosha and I'm a VFX supervisor for Mr. X, the studio behind titles like The Shape of Water, Roma, Shazam, and Scary Stories to Tell in the Dark, which is the film I'll be talking about today. Scary Stories is directed by Andre Overdell and produced by Mr. X's longtime collaborator Guillermo del Toro. This brings me to the character I'll be talking about today, which as you can see on my screen is the Jangly Man, and how Mari was used in our pipeline in the development of our creatures here at Mr. X. I was the CG supervisor at the time on this show, but I was personally involved in the creature workflow of this, especially in the early on texturing process, and then at the end with the look dev and the shading work. Mari is our go-to tool here at Mr. X, particularly for creatures, and it's helped not only streamline the whole process, but get very predictable results very early on, which help us deliver the work faster and more efficiently. And primarily that's due to the ability to see the changes in real time, and these changes represented on a shader like the principled BRDF gave very similar results to the custom RenderMan setup we had at the time. Now I know Pixar Surface is now also available in here, and we're currently using that, and it gives even more accurate results. But the principled BRDF was more than sufficient to give us very good predictable preview, as you see here, of what our final render would end up looking like. A little context on the Jangly Man and on the project itself. The Jangly Man is basically a corpse that's made up of limbs from several different bodies which come together to form a whole terrifying monster. As you can see here, it's very decrepit and rotting away with exposed pieces of bone and muscle and flesh, which were based off a very lovely practical suit that we had. As you can see here, the reference. Granted, the reference looks a little bit warmer. That's because the HDR is contributing to this. So if we were to view just the color map, now we're in the same world. But we're using HDRs from set and from some of the shots so that we see how it plays in context in the shot itself. Our studio created a narrated VFX breakdown where we talk about the creation of all of these monsters in the film, which we can post to the group after the talk if you're interested to learn more. One of the main notes we worked towards with every shot on this project was to maintain a realistic feel while enhancing the creatures to feel as scary as possible in the context of the PG-13 rated film. Given reviews of the film, I'd say we hit our mark pretty well in fooling the audience, with the exceptions of when the jangly man pieced himself together limb by limb, which of course there was no way for our actor to have performed that. The way we generally start these creature-based projects or any digidoubles that we work on, we start with an in-house scan, photogrammetry scan of our actors. Came in with the practical suit, and I can show you here. If we turn these guys off and come here. So if we view this guy on flat, so this was the solved textures from the scan. Well, we have a little bit of issues here, like you can see in between the toes and underneath. Here, of course, where the photo scan had a little bit of trouble capturing all the data, but no matter, because we always do a secondary survey, which is a very high-res survey for textures only, where we get both polarized and cross-polarized photos, and we basically use this as a roadmap. So this is basically our retopoed low poly body. We brought it back into reality capture where we initially solved the scan to reproject the color map onto this to give us, as I mentioned earlier, a roadmap of where all the detail goes. And this will allow us then to come in with the high-res images and get in close and start painting and projecting and cleaning up any parts where the scan might have missed, such as these, or where it just didn't quite solve the resolution we would like and the texture is very soft. And then if we go to our jangly man here, start going flat. So this was where we went in and projected higher res textures and got all that fancy detail that we needed. But basically, once we have the color map all projected, then maybe go to specular and roughness and start with just flat values. So basically, if we can go to the rough, so let's view this back to our full shader again. So if I get a base value here, I will use this. We also had a coat layer here that I'll talk about as well, since the jangly man had to be a lot in the rain. That's why he always looks a little bit shiny, as if he just got rained on or if he's profusely sweating. But we'll go in with, let's say, a value where we can fine-tune in real time and see exactly what kind of specular levels, or rather what kind of roughness levels we want in our map, and so on with all of the channels basically. This then allows us to, once we do paint any maps, let's view the current channel here. So once we do paint our roughness maps, which this was a lot of procedural maps in Mari. Actually, some of the brushes in Mari, like if we go here to, so if we go here to shelf, some of these brushes are really, really great. I believe the vascular one was initially what I was using back and forth, with layering it differently until I got a nice pour-like texture of this. Now, of course, you can do many other ways. Extract it from the photo survey, extract from details in textures from texturing XYZ, but at the time this was a little bit of a mixture between extracting from our color map and doing some procedural stuff with some of, quite frankly, great brushes that you have at your disposal just out of the box here. Now, as I mentioned, one of the things here that we tend to turn off our generic lights here and bring in an HDR that's representative of the scene and what we're going to see in the final shots. To be honest, usually I'll test more than just one HDR. I'll bring a bunch of scenes and see how each one of them looks. I'll start rotating the lights and see, for example, how the speck starts playing off our character, and start seeing if this is giving me the result I'm expecting or not. So here it is, just the normal speck of the skin without the raindrops that I showed earlier in the coat layer. So if I go back to now my layers, turn on the coat layer, which gives us that more wet look from being rained on. It's just a nice way to visualize it in real time and make sure that, you know, the detail is there in the ballpark where I would expect, and I could predict what I'm going to get in the final render. Of course, you've probably noticed while I was on the channels layer or in the shader layer, there's a lot of other channels that I'm missing here. For example, the mean free path color and depth, and all of our other maps that make up the whole shader. That's because this is basically a curated file that I've done for the presentation, just to kind of give a broad overview of how we use Mari in the creature pipeline. But yeah, this is basically the gist of it. And once we like the results and everything, we export. We plug them into our shader as just initially a plug and play, and see how close it gets to what we saw here, and make sure that we don't get anything unexpected. And then we start building the rest of the maps and building that shader up. Mari has made huge advancements over the years, especially over the years that I've been using it for. I remember using the very early versions of Mari where we didn't have these shaders that were representative of what we might see in our render engines. And, you know, we paint the maps, then export the maps, take them to our render engine, build a shader, render, see what works, what doesn't work, go back, try to adjust those maps again, export them back out, bring them back to the shader. And it was so much back and forth that it just made this makes the process a lot more streamlined and quick when you can view it in real time, such as this. And yeah, that's basically the gist of how we use Mari here in our creature pipeline. And Mr. X, thanks for having me.